Section 9.6 Matrices and matrix operations. As you can see right here, we have a system of two equations and two unknowns. We can also use the coefficients of these coefficients in order to write the system as an augmented matrix. So look at this. I will have two rows and then three columns. And I will only use the coefficients to put that into the augmented matrix. So to start with a matrix, we need the two square brackets. On the right-hand side of each equation, we have the two constants. So in the matrix, we put the right-hand side on the right column, and then the other coefficient is on the left. So on the first row, I will have 3, 4, 7. And on the second row, I will have 4, -2, 5. This is called an augmented matrix. We have the first column represents the coefficients of x. The second column represents the coefficients of y. And the last column represents the constant on the right-hand side. The first row represents my first equation. The second row represents my second equation. So in order to convert from the system of linear equations into augmented matrix, we need to rewrite the equation in standard form. We need to have the equations in this form in order to be able to convert that into the matrix form. We can also create a matrix that only contains the coefficient. For example, if we create the matrix with only 3, 4, 4, and -2, that matrix is called the coefficient matrix. So this is the coefficient matrix because it only contains the coefficient of x and the coefficient of y. So that's the difference between the augmented matrix and the coefficient matrix. Example 1. Write the augmented matrix for the given system of equations. I have a system of 3 equations and 3 unknowns. I will have 3 rows and 4 columns. But before I convert that into a matrix form, I will need to make sure that all of my equations are in the standard form, which means all of the terms with variable are on one side and the constant is on the other side. So I have the notation for matrix. I will have my constant on the right side. The first row will have 1, 2, -1, 3. The second row will have 2, -1, 2, 6. The last row will have 1, -3, 3, 4. This is my augmented matrix from the system of linear equations. Example 2. Find the system of equations from the augmented matrix. So in this case, they gave me the augmented matrix and they want me to write the system of the equations in terms of x, y, and z. So I have 3 rows. That means I have 3 equations. And from here, I have x, y, z, and then the constant on the other side. So my first equation is 1x minus 3y minus 5z equals -2. My second equation will be 2x minus 5y minus 4z equals 5. My third equation will be -3x plus 5y plus 4z equals 6. So this is my system of 3 equations with 3 unknowns that is written from the augmented matrix. Next, we will learn how to use a matrix to solve for the system of linear equations. In order to do that, we will need to use row operations to turn our matrix into an echelon form. So in an echelon form, your diagonal must be all 1. And every element below the diagonal must become 0. To solve the system of equations, we can perform the following row operations. First, interchange rows. You can change the order of the rows. You can move the first row to the bottom or the third row to the top. Second, multiply a row by any constant. You can multiply any row by any constant that you want to. Third, add the product of a row multiplied by a constant to another row. So you can add one row to another row, or you can multiply one row by a number and then add it to another row. So these 3 are the 3 valid operations that you can do. Example 3. Solve the given system by Gaussian eliminations. The Gaussian elimination method refers to a strategy used to obtain the row echelon form of a matrix. So basically, you want to rewrite your system in a matrix form and try to rewrite it into the echelon form. So first, I will need to put this system. First, I will need to write this system into a matrix form. I will have 2 rows and 3 columns. The first row will have 2, 3, 6, and the second row will have 1, -1, 1/2. This is my augmented matrix from this system, and I want to use the Gaussian eliminations, which means I want this matrix to become the echelon form. The question is asking me to use the Gaussian eliminations, which means I start up with my original matrix and I want to turn that into the echelon form. So in order to have a matrix in an echelon form, my diagonal must be 1, and then the numbers below the diagonal must be 0. So this is my diagonal. I want this to be 1 and I want this to be 1. And I have to use the valid row operations. So the row operations that I can use are swapping the 2 rows. So from here, I notice this number is 1. If this row becomes the first row, then my first element in the diagonal is 1. So what I'm going to do is swapping the first row and the second row. So this little notation saying that I am swapping row 1 and row 2. So row 1 will become row 2 and row 2 will become row 1. My row 2 becomes row 1 and my row 1 becomes row 2. Now I have this one is 1. Now I want to turn this into 0. So remember, we can add the 2 equations. However, if I take 1 add 2, that will not give me 0. In order for this to become 0, I need to take -2 add 2. So what I would do, I will take the row 1 multiplies by -2 and add to row 2. So this notation say my new row 2 will be equal to -2 row 1 plus the original row 2. This process will only change this row 2 to a new row 2. It will not do anything to my row 1. So my row 1 will stay the same. 1, -1, 1/2. For row 2, we need to use this operation in order to get to the elements in row 2. So in row 2, we have 3 elements. in order to get to the first element right here, I need to look at the first column. I'll take negative 2 times row 1 plus row 2. Negative 2 times 1 plus 2. Negative 2 times 1 is negative 2 plus 2 is 0. For the second element, I'll look at the second column, negative 2 times negative 1 plus 3. Negative 2 times negative 1 is 2 plus 3 is 5. So this element is 5. For the third element, I'll look at the third row. 1/2 times negative 2 plus 6. 1/2 times negative 2 is negative 1 plus 6 is 5. So now my new matrix is 1, negative 1, 1/2, 0, 5, 5. This is my diagonal here. This is not in the echelon form yet because this is 1 and this is not 1. I want to turn that into 1. So I'm using one of the valid row operations. In order to turn 5 into 1, I will need to divide this by 5. So I will divide the whole row by 5. So this notation says the new row 2 will be equal to 1/5 times row 2. Doing this process does not do anything to my row 1 because this formula is only applying to my row 2. So my row 1 will stay the same. 1, negative 1, 1/2. Now for my row 2, I have 3 elements as well. And to get to these 3 elements, I need to use this rule. I need to take 1/5 times the element in the previous row 2. So my previous row 2 is here. So I will take 0 times 1/5, 5 times 1/5, and then 5 times 1/5. 0 times 1/5 is 0. 5 times 1/5 is 1. 5 times 1/5 is also 1. This matrix is in the echelon form because our elements in the diagonal are 1 and the element below the diagonal is 0. So I will stop right here and I will write it back into the equation form. I have 1x minus 1y equals 1/2. 0x plus 1y equals 1. And that is equivalent to x minus y equals 1/2 and y equals 1. So by doing so, I found my y. Y is 1. To find x, I'll substitute 1 in here and then solve for x. So I take 1 and substitute that in for y. And I have x minus 1 equals 1/2. To solve for x, I will add 1 to both sides. X equals 1/2 plus 1. X is 3/2. So my answer in the order pair will be 3/2 comma y. My solution in order pair will be x comma y, which is 3/2 comma 1. Example 4. Use the Gaussian elimination to solve the following system of equations. So I have a system of 2 equations and 2 unknowns. I want to use the Gaussian eliminations, which means I need to start with my matrix and want to turn that into echelon form. I will have 2 rows and then 3 columns. My first row is 2, 1, 1, and the second row is 4, 2, 6. And I want to turn this matrix into this format, where my diagonals are 1 and then everything below the diagonal is 0. This is my diagonal. I want to turn this into 1, this into 1, and this into 0. So this is 2 and this is 4. So I'm not going to swapping the two rows because this is 4. If this is 1, then I'll swap it. Now, this is 1 and this is 2. You cannot swap the column, so don't even think about it. So I cannot swap the rows. Right now, in order to turn this 2 into 1, I will need to divide this by 2. So what I will do is divide the whole first row by 2 to turn this into 1. So this notation says my new row 1 will be the original row 1 multiplied by 1/2. So if I take 2 multiplied by 1/2, I get 1. If I take 1 multiplied by 1/2, I have 1/2. If I take 1 multiplied by 1/2, I will have 1/2. This operation will not do anything to my row 2, so my row 2 will stay the same. 4, 2, 6. So I have the diagonals. This is already 1. I want this to be 1 and I want this to be 0. So I will turn the 4 into 0 first. Remember, we can add 2 rows. If I take 1 plus 4, that is 5. That's not 0. In order to add the 2 rows and make this 4 to become 0, I need to take -4 plus 4. So I will multiply the first row by -4 and add to the second row to get to the new second row. So row 2 will be -4 times row 1 plus row 2. This is a formula. That is how I get to the new row 2. Now, this process does not do anything to my row 1. So my row 1 stays the same. 1, 1/2, and 1/2. For my row 2, I have 3 elements. And for each of these elements, I am using this rule right here. So for this element here, I need to take -4 times row 1 plus row 2. So I take -4 times 1 plus 4. -4 times 1 plus 4, that is 0. For this second element, I'll take -4 times row 1 plus row 2. So -4 times 1/2 plus 2. -4 times 1/2 is -2 plus 2 is 0. For this third element here, I'll take 1/2 times -4 plus 6. So 1/2 times -4 is -2 plus 6 is 4. So at this step, I cannot continue because I have 1 here, 0 here. This is not 1, this is 0, but there's nothing else I can't do. So I'm going to stop right here. I will rewrite that back into my equations. 1x plus 1/2 y equals 1/2. 0x plus 0y equals 4. So the second row gave me the equation 0x plus 0y equals 4, which is 0 equals 4, which means the system is inconsistent and has no solution. Example 5. Solve the system of equations. I have 3 equations and 3 unknowns. In this question, they did not ask me to use the Gaussian elimination method. However, I will still use that method. Now, before I put this system into a matrix form, I need to rewrite these equations a little bit. So for the first equation, I have negative x minus 2y plus z equals negative 1. For my second equation, I have 2x plus 3y. I don't have a z, so that is 0z equals 2. For the third equation, I don't have x. That means I have 0x plus y minus 2z equals 0. So from here, I will have 3 rows and 4 columns matrix. My first row will be negative 1, negative 2, 1, negative 1. My second row will be 2, 3, 0, 2. My third row will be 0, 1, negative 2, 0. And I want to turn this matrix into an echelon form, which means all of the elements in my diagonal must be 1, and everything below that must be 0. The first element in my diagonal is negative 1. I want this to become 1. So I will multiply this by negative 1. So what I'm going to do is multiply the first row by negative 1. So this means my new row 1 will be equal to the original row 1 times negative 1. So negative 1 times 1 is 1, negative 2 times 1 is 2, 1 times negative 1 is negative 1, and then negative 1 times 1 is 1. So my first row will be 1, 2, negative 1, 1. Now, this process does not do anything to my row 2 and 3. So my row 2 and 3 stays the same. So my first element in the diagonal is 1. Now I need this to be 1 and this to be 1. So notice that this is 1 right here. So if I'm swapping row 2 and row 3, then this second element in my diagonal will be 1. So I'm swapping row 2 and row 3. Row 3 will become row 2 and row 2 will... Next, I want to turn this 3 into 1. So notice that this element is 1. So if I'm swapping the row 3 and row 2, this will be 1. So my row 3 will become row 2 and my row 2 will become row 3. So this notation is saying that I'm swapping my row 2 and row 3. Row 1 stays the same. 1, 2, negative 1, 1. Now row 3 will become row 2. So 0, 1, negative 2, 0. And row 2 will become row 3, 2, 3, 0, 2. This is my diagonal. I have 1, 1, 0. There's nothing I can do with the 0 yet. So next, I will just turn the elements below the diagonal to 0. So this is 0 already. I need to turn this 2 into 0 and this 3 into 0. To turn this 2 into 0, I will need to use the first row. So if I take this 1 times negative 2 plus 2, then that will be 0. So what I'm going to do, I'll take row 1 times negative 2 and add to row 3. So this notation say my new row 3 will be equal to negative 2 times row 1 plus row 3. This process will not affecting row 1 and row 2. So my row 1 and row 2 stays the same. 1, 2, negative 1, 1. 0, 1, negative 2, 0. To get to this element, I'll take 2 times negative 2 plus 3. 2 times negative 2 is negative 4 plus 3 is negative 1. To get to this element, I'll take negative 1 times negative 2 plus 0. Negative 1 times negative 2 is 2 plus 0 is 2. And then to get to this element, I'll take 1 times negative 2 plus 2. 1 times negative 2 is negative 2 plus 2 is 0. So this is my diagonal right here. These two are 0. Now I need to turn this negative 1 into 0. In order to do that, I'll take row 2 plus row 3. So my new row 3 will be the previous row 2 plus the previous row 3. My first and second row stay the same. 1, 2, negative 1, 1, 0, 1, negative 2, 0. Now, to get to this element, I'll take 0 plus 0, which is 0. To get to this element, I'll take 1 plus negative 1, which is 0. To get to this element, I'll take negative 2 plus 2, which is 0. And then to get to this element, I'll take 0 plus 0, which is also 0. So at this point, even though the diagonal are not all ones, but everything below are 0. And if you notice that the last row, you have 0x plus 0y plus 0z equals 0, which is you have 0 equals 0. So I'm going to stop right here and put these back into the equations form. The first equation is 1x plus 2y minus 1z equals 1. The second equation is 1y minus 2z equals 0. And the third equation is 0 equals 0. So what does that mean when you have a statement that is an identity, because you have 0 is actually equal to 0? So this system is a dependent system, which means you have an infinite number of solutions. So in this system, we have infinite number of solutions. Now, what if they asked you to put the solution into the triple order? When you have the system with infinite number of solutions and they want to put that into this triple order, you are going to have x, y, z. So the first coordinate is always x. And then you're trying to write y into an expression in terms of x and z into another expression in terms of x. So in order to do that, I need to use the relationship between these two. I am out of room here, so I am going to move to the next page in order to show you how to do that. But first, let's copy these two equations. So these are the two equations that I had after simplifying my matrix. So I'm going to rewrite this into y equals 2z. So I'll just bring the negative 2z to the right side. And what I'm going to do now is substitute y with the 2z because I know y is equal to 2z. So I take this 2z and substitute that into for y. So I take this 2z and substitute that with y. So I have x plus 2 times 2z minus z equals 1. So I have x plus 4z minus z equals 1. 4z minus z is 3z. So I have x plus 3z equals 1. Now, I need to solve for z. So I'm going to subtract x from both sides. I have 3z equals 1 minus x. And then divide both sides by 3. So z is 1 minus x over 3. So z is equal to 1 minus x over 3. So if I go back to my order triple, if I go back here in my order triple, this is the place for z. And z is equivalent to 1 minus x over 3. So I'm going to put 1 minus x over 3 here. And next, I would do the same thing for y. I'm going to find y in terms of x. So from here, I know that y is equal to 2z. And z is 1 minus x over 3. So I'm going to substitute 1 minus x over 3 in here for z. So z is equal to 1 minus x over 3. And I substitute that in here. So my y is equal to 2 minus 2x over 3. So if I go back to my order triple, this is the place for y. And y was equal to 2 minus 2x over 3. So I will put 2 minus 2x over 3 in here. And this is my solution in order triple. Example 6. Solve the system of equations using a calculator. So in order to use a graphing calculator to solve for the system of linear equations, we need to put these equations into the matrix form. So I'm going to go ahead and put that into the matrix form. For the first row, I have 5, 3, 9, negative 1. For the second row, I have negative 2, 3, negative 1, negative 2. For the third row, I have negative 1, negative 4, 5, 1. So I have a matrix with 3 rows and 4 columns. So this is called 3 by 4 matrix. And I am going to enter this matrix into my calculator. I am going to show you how to use the TI-84 calculator in order to solve a system of linear equations using matrix C. If you have a TI-84 calculator or TI-83 calculator, it will work the same way. Now, if you don't have a graphing calculator, don't worry. I have also including the link to use it for free online. So if you're in our Canvas page, go to Modules and then click on this link. In this page, I have included the instructions here, but you can just click on this link and then click here, click here. Now, don't worry about this test. We are here just for the calculator. So you're gonna click on this calculator icon here. And this is our calculator. In order to enter the matrix into the calculator, we will need to use this button, say matrix, but that is in blue, so we need to click on second matrix. And in here, we have names, math, and edit. We will need to use the right arrow to select edit in order to enter the matrix in. So while you're here, you can choose A, B, C, D, or whatever matrix that you feel like to. It doesn't matter which one, as long as you remember where you save it. So I am going to choose A, and then enter. They'll ask how many rows there are in your matrix. So I have 3 rows. I hit 3 and then enter. And then how many columns do you have? I have 4 columns. So I hit 4 and then enter. Now I will need to enter every element in this matrix. I have 5, enter, 3, enter, 9, enter, negative 1, enter. Now, when you're entering the negative number, use this button right here. Do not use this key. This keys represent a subtraction, and this keys represents a negative. Negative 2, 3, negative 1, negative 2. Negative 1, negative 4, 5, and 1. Always double check to see if you enter them correctly. Now, after you've entered your matrix in your calculator, you want to go back to the main screen. So in order to do that, you click on Second Quick. This is my main screen. Now, I want to use my calculator to do the row operations for me. In order to do that, I need to go back to matrix. So second matrix. Now, I need to go to math, and then I go down and choose REF, enter. Now, I want them to do the row operations for me. Now, I want to tell them which matrix to work on. So I'm gonna go back to matrix, second matrix, and under the names, I will choose the matrix that I used to save my matrix in. Remember, I saved that in A, so I'm gonna choose A, enter, and then close the parentheses and hit enter again. So they did the row operations for me, but they have it in terms of decimal. If you want that to be in fraction, then you click on math, and then you choose fraction, and then enter, and enter. They have this in terms of fraction for you. So be careful when you do your homework. Always read the instruction. If the instruction doesn't ask you to round, then please give them the exact answers. My calculator helped me to turn my matrix into an echelon form. Now all I have to do is just copy my matrix down. I have used my calculator to turn my matrix into an echelon form with the diagonals are 1 and the numbers below the diagonals are zeros. Now I will need to turn this back into the equations forms. So I have my first equation is x plus 3 over 5y plus 9 over 5z equals negative 1 over 5. The second equation is y plus 13 over 21z equals negative 4 over 7. The third equation is z equals negative 24 over 187. So this is my answer for z. Now I need to substitute this in here in order to solve for y. So after substituting z in, I have y plus 13 over 21 times negative 24 over 187 equals negative 4 over 7. So now I am going to multiply these two fractions, and I have negative 104 over 1309. And in order to solve for y, I'll just add this fraction to both sides. Negative 4 over 7 plus 104 over 1309 is equal to negative 92 over 187. So I have z and y. Now I need to substitute y in here and z in here in order to solve for x. So I have x equals 3 over 5 times y, which is negative 92 over 187, plus 9 over 5 times z, which is negative 24 over 187, equals negative 1/5. So next I need to multiply these two fractions and these two fractions. So 3 over 5 times negative 92 1 over 87, I get negative 276 over 935. 9 over 5 times negative 24 over 187, I get negative 216 over 935. Now I am going to combine these two fractions. I'll get negative 492 over 935. And I end up with x minus 492 over 935 equals negative 1/5. In order to solve for x, I'll need to add this fraction to both sides. So x is equal to negative 1/5 plus 492 over 935, which is 61 over 187. So now I'm going to put my answers into the order triple. I will have x, y, z. X is 61 over 187, y is negative 92 over 187, and z is negative 24 over 187. So here is one of the homework questions. They are asking you to add the two matrices. When you want to add the two matrices, make sure that they have the same dimension. So this is 2 by 3, this is also 2 by 3. So that means it's possible to add the two matrices. When you want to enter your answer as a matrix, you click in here and click on More in order to read the instruction on how to enter them in. So basically, your matrix will start with a square bracket and stop with a square bracket. And inside the square bracket, you will have two rows. So they are separated by a comma. And each row, you will put them into a pair of parentheses. So I have a matrix with two rows. And then in each row, I have three elements. So for the first row, I'll take A plus negative 10, that's negative 2, comma. Negative 8 plus 1 is negative 7, comma. 0 plus 4 is 4. That is my first row of my matrix. The second row, negative 8 plus negative 3 is negative 11, comma. Negative 7 plus 0 is negative 7, comma. Negative 10 plus negative 4 is negative 14. This is my second row. So this is how I enter the 2 by 3 matrix in here. Now, if you have 3 by 3 or 4 by 4, you will do the similar. Now, for this question, they gave me two matrix C. The first one is 2 by 3 and the second one is 3 by 1. And they ask, is it possible to take A times B? So you look at this A times B. Now, it's possible if the number of columns in A matches the number of rows in B. So in this case, A has 3 columns and B has 3 rows. So yes, it's possible. And then after that, you are going to multiply this and put your answer in here. I am going to show you how to multiply these two in a calculator. I need to enter A and B into my calculator. So I need to go under matrix, second matrix, and then go to edit and choose A. My matrix A is 2 by 3. So I have 0, 5, 5, negative 5, 2, 3. And next I will need to enter my matrix B in here. So I'm gonna click this, go back to matrix, second matrix, and go to edit and choose B. B is 3 by 1. So I have 3, 5, negative 3. And then I go back to the main screen, second, clicked. Now I need to take matrix A times matrix B. So second matrix, under the names, I'll get A, and then multiply second matrix and select B and enter. this is my product of matrix A times matrix B. So I have 10 and negative 14. My question is it possible for me to take B times A? What happens if I swap the order? Instead of A times B, now I take B times A. Is it possible? Well, you can check it out. If you go back to your calculator and you take matrix B times matrix A. There's an error. It says that dimension mismatch. What does that mean? So remember, when we take A times B, the number of columns in A need to match the number of rows in B. So A has 3 columns, B has 3 rows, so they match. You can multiply them. Now, if you take B times A, B only has 1 column and A has 2 rows. 1 doesn't match with 2. So that's why you cannot take B times A. You can also watch more videos on how to multiply 2 matrices. In this question, they gave me the price of the car based on the brand and the type of the car. So I have 2 different brands and 4 different types. And they also gave me the profit that the dealer makes on each type of the car. So on compact, they make 8%. On mid-size, they make 13%. On luxury, they make 14%. And on pickup truck, they make 21%. And they put that into a matrix. So now, in order to find the profit matrix, you need to multiply these 2. So I will enter this into one matrix and then this into another matrix and multiply them. So I'll go to matrix and edit. I'll save the first one in C. I have 4 by 2. So I get 15,000, 11,000, 21,000, 19,000, 30,000, 34,000, 44,000, and 50,000. Right, so after I enter my matrix in, I need to go back to the main screen. I'll hit second, quit. Now let's enter my second matrix in. Second matrix, edit, and I'll enter that in D. I have 4 by 4. So I have 0.08, and the rest on my first row is 0. On the second row, the second element is 0.13. The third row, the third element is 0.14. The fourth row, the fourth element is 0.21. Alright, so to find the profit, we need to take the price of the car times the percentage of the profit. So now, we need to take the product of the 2 matrices. Is it possible for me to take matrix C times matrix D or matrix D times matrix C? Alright, so go back here, let's test it out. So if I take matrix C times matrix D, error that say dimensions mismatch. So what does that mean? It means that I have 2 columns here, and in this one it has 4 rows. They don't match. So if I want to multiply these matrices, I need to take D times C. because on D I have 4 different columns and on C I have 4 different rows. So I need to go back here and I'll take matrix D times matrix C. So this is your profit matrix, and we are going to enter that in here. This column represents the profit that you make from selling brand A, and this column represents the profit that you make from selling brand B. This row represents the profit that you make from selling compact car. This row represents the profit that you make from selling midsize. This row is the profit that you make from selling luxury. And this row is the profit that you make from selling pickup truck. Now, for example, for every compact car that you sell in brand A, you make about $1,200 in profit. Or for every luxury car that you sell in brand B, you make about $4,760 in profit. Last question. How much profit does the dealer sell 3 brand A pickup trucks? So this is the profit for brand A, this is the profit for brand B, this is the profit for pickup truck. So brand A pickup truck, that means that for every 1 pickup truck that you sell in brand A, you make $9,240. Now if you sell 3 of them, what is your profit? You take this times 3.